In this section, we're going to focus on quadratic functions and their applications. We're going to look at writing a quadratic function in standard form and a vertex form, identifying the vertex of a parabola, graphing quadratic functions, stating the domain, range, and then identifying key points on the graph, and then finally solving applications. So I want to introduce this lesson by just reminding you of the graph of y equals x squared, which is one of those 7 basic functions that we talked about in section 11. Recall that y equals x squared has a graph of a parabola whose vertex is at the origin, that is the point 0, 0. It goes through the points 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Let's also remind ourselves of a few other things, that the domain of this function is all real numbers, right? As we go from left to right, the graph extends infinitely in each direction with no gaps or jumps. And then the range of this function, if we read the graph from bottom up, the smallest y value is at the y value of 0, and the graph extends infinitely upwards, which goes to infinity. Because the parabola opens up, the vertex is actually at a minimum point, and therefore we say that there is a minimum value, which is the y value of the vertex, or 0. Also, because the vertex is a turning point in the graph, notice that the graph is going down or decreasing until we get to the vertex, and then the graph is increasing after. And so we say that the graph is increasing on the interval, open parentheses, 0 to infinity, that is to the right of the vertex, and it is decreasing from negative infinity to 0. Now, we'll look at some transformations of this basic function y equals x squared. And I've already got the graphs drawn on the screen for each of these, but I just want to bring these things to remembrance that we've talked about. The graph of g of x, which is equal to the quantity x minus 3 squared, if you recall, that is a graph of f of x equals x squared shifted right 3 units. Notice that there's an inside change, that is something happens to x, and if we set x minus 3 equal to 0, we find that x is equal to 3, which implies that there is a shifting right of 3 units. And that's exactly what the graph on the screen shows. I have the basic y equals x squared in this dotted gray graph, and the shifted graph moves the vertex of 0, 0 right 3 units to 3, 0. And then the graph of that x minus 3 squared is shown as well. If we consider the graph of g of x, which is equal to x squared minus 4, notice that there's a transformation of the basic function with an outside change, that is a subtraction of 4. So this is a graph of f of x equals x squared shifted down 4 units. Therefore, this vertex of 0, 0 on the basic graph goes down to 0, negative 4. If we look at the graph of g of x, which is equal to the quantity x plus 2 squared plus 1, there's an inside change of a plus 2 and an outside change of plus 1. So remember, the inside change tells us how things are going to change horizontally or in the x direction, and the outside change tells us how things will change vertically or the y direction. So because of the x plus 2, when we set that equal to 0, we get x is equal to negative 2. So there is a shifting left 2 units, but the outside plus 1 means that we will go up 1. So follow the change from the original function, that is a vertex of 0, 0. We have to go left 2 and up 1, which takes us to the vertex of negative 2, 1. Now keep in mind all of those other points are going to shift in that same direction, but I'm just wanting you to identify how the vertex is obtained through these transformations. And we'll do one more of these transformations that combines a few more things. We have the graph of g of x, which is equal to negative, then the quantity x plus 2 squared plus 1. So again, we see that inside change of plus 2, which is a left 2 units. The plus 1 on the outside means that's going to go up 1. And then remember this negative on the outside. To take the opposite of f of x is the opposite of y, and the opposite of y occurs across the x-axis. So this is a reflection across the x-axis. And so in the proper order, we have to first move things left 2 units, then reflect across the x-axis, and then shift up 1. So this will give us a parabola that has a vertex of negative 2, 1 that opens down and goes through negative 3, 0, negative 1, 0, and also the y-intercept of 0, negative 3. So the main observation that I want you to take from this is that functions of the form y equals a times the expression x minus h squared plus k for real numbers a, h, and k with a not equal to 0 are transformations of y equals x squared, and the vertex of the new graph is the ordered pair hk. So that is the h and k from that function tell us what the new vertex is. And keep in mind this x minus h. So the minus is built into this notation, which means that we're taking the opposite of whatever's inside parentheses. And recall that a is a stretch factor. So remember that determines if the graph is going to be stretched vertically upward or shrunk vertically down, depending on if the value of a is greater than 1 or between 0 and 1. The value of h determines how the graph shifts horizontally. K determines how the graph is shifted vertically. And if we have a negative sign on the outside, that is if a is less than 0, the graph is also reflected across the x-axis. So we're just putting together all of the things that we talked about in section 11, but specifically to the graph of y equals x squared.